Hello and welcome to a quick demonstration of the Pulsar watermarking feature that we have been working on for the hack. Firstly, let me just thank the team for their great contribution to this effort. Thanks go out to Giannis, Murthy, and Jennifer for their great work on this. What I'm going to quickly show you is a prototype that that teaches Pulsar how to broker the transmission of event time watermarks from producer to consumer. Let's just look at this quick demonstration. Here we have a Pulsar broker, the Pulsar standalone running in this window here like normal. Now what we're going to do is use a pair of consumer and producer to show that the producer can not only just generate messages, but can also now generate watermark information that gives the consumer a hint about the progression of the event time component of the messages. In this way, a consumer can actually make better decisions about the progression of the event time domain. Now, in the application we're going to see, the producer generates some amount of disorder. So it generates some messages that are out of order in event time, and then produces a watermark to signal that all the events have been produced up to a certain point in time. The watermark is accurate in the sense that though the events were out of order, the watermark is still a newer timestamp than any of the events that were produced. Now on the consumer side, we're going to show how we can actually sort these messages back into event time order. And this is pretty straightforward how this works. So let's first start our consumer. Now the consumer is just waiting for messages, and I'm just going to quickly run the producer now. Now the producer produces a bunch of messages, and we start to receive them in this consumer listener here on the consumer side. But what's going to happen is we're simply going to buffer these messages. All right, so nothing will actually be emitted until later when we receive a watermark from the broker. The watermark says, hey, you've gotten all the messages up to a certain point in time. And so now this consumer goes and drains the buffer that it had and actually sorts the outgoing messages into event time order, because it's using the watermark to sort of make that determination about, how much, what is ready to be flushed. So if we look at the program output, let's just scroll to the top, you'll see that we first received a bunch of messages, and within these timestamps, which are shown here, there is some degree of out of orderness. And then finally we get a watermark, and the watermark tells us to flush everything out, and we now can produce messages in event time order. So this is a streaming ordering consumer, one of the many demonstrations of watermarking. In the future, we'd like to show that this sort of watermarking can also be used to coordinate multiple consumers of a single subscription. So in our prototype, we do support both exclusive and shared subscription modes, and watermarks are actually generated as messages are acknowledged. And so what would happen in, for example, a shared or key shared situation is only if the watermark would be kind of conservative. It wouldn't advance until messages were acknowledged in one consumer across all the consumers. So the watermark is sort of conservative across all the consumers of a subscription. Again, thank you.